So now to find the second rocket equation, what we want to do is realize that as you're spewing stuff out the back of the rocket, that you do have a changing mass. So that means that mass is not constant. And so we say, well, what does that mean? Okay, how do we apply non-constant mass to try to figure out what's going on here? Okay, because I want to find the velocity at some future time. So that means our favorite equations all the way back, our favorite equations that we had back all the way in chapter 2 do not apply, because these only apply in the event of constant acceleration. And clearly, if the mass is not constant, if the thrust is constant, so if dm dt, minus dm dt r, if that's a constant, if the exhaust velocity is constant, then that means that the mass is changing and the acceleration cannot be. So we had said that minus dm dt times, I'm going to use v naught or ve, I suppose, for the exhaust velocity. So that's going to be the exhaust velocity here, and so that's the velocity relative to the spacecraft. Okay, and that's equal to ma. Okay, and so I want to solve for a. So a is, I want to find the acceleration. So a is v sub b, or minus v sub b 1 over m dm dt. A is dv dt. So dv dt is minus v sub b 1 over m dm dt. Okay. So, pretend these are fractions, cancel the dt. So that gives me that dv is going to be equal to minus v sub b 1 over m dm. I want to just get v, so I'm going to do an integral of both sides from initial to final. So that would give me v final minus v initial equals minus v sub b integral from initial to final 1 over m dm. So what is the integral 1 over m dm? Well, you should know that. Okay, so that should be in calculus 1. So that is the natural log of m evaluated at initial and final. So v final minus v initial is going to be minus v sub b natural log of m final minus natural log of m initial. Okay, so I can take this and look at it and say v final minus v initial equals minus v sub b natural log of m final over m initial. The difference of the logs is the log of the ratio. I can fold the negative in there. V final minus v initial equals v sub e, okay, natural log of m initial over m final. Okay, and that's because the minus log of x equals the log of 1 over x. Okay. Well, now I can put this all in one thing. So v final equals v initial plus v sub e natural log m initial over m final, or using the notation we've been using, v for final velocity equals v naught initial velocity plus v sub e natural log m initial over m final, and that is Minkowski's second rocket equation. So now all we have to do is apply these things.